in order to figure out what sound intensity actually is, I have given you a reference, right? It is 1 trillion watts spread, like 1 trillion people spread about with 1 watt of energy. That's my reference. Now, what can I hear beyond that is given by something called intensity. What is an intensity of a wave? So intensity of a wave is power per unit area. So remember we were doing pressure. What was pressure? Force per unit area. And what was power? Energy per unit time. So intensity is energy per unit area times time. So the amount of energy that's spread over a particular area in a given time. That's what intensity is. And the SI units for intensity are watts per meter squared. And this is how the sound wave becomes smaller as you go away from the source. So imagine this is your source. This is me standing in the middle. As you go away from the source, so say at 1 meter, the sound goes down by 4 pi r squared. So this is 1 meter. This is now 2 meters, and this is now 3 meters. So 1 meter, 2 meters, 3 meters. So sound goes down by the factor of r squared. So this is how sound becomes divided. You would think that the intensity goes down, 1/2, 1/3, 1/4. No, it's actually squared of that. And the formula is intensity goes down watts divided by 4 pi r squared. So if somebody asks you, given r as 1 meter, how much intensity will that be? Just take watts divided by 4 pi. R equals 1. And a good reference is this picture here. So imagine at 1 meter, if the intensity was 120 watts per meter, at 2, it will be just 30. At 3, it will be 13. At 4, it will be 7.5. And at 5 meters, it will be 4.8. Goes down really, really fast. So the sound intensity almost goes down as whoop. Sound has very, very little power. Oh, and then I have to define what an isotropic source is. An isotropic source is a source that emits the same amount everywhere in all 3 dimensions. Yes. In what? Which one? So if it asks you, for example, let's suppose it'll ask you, okay, if the intensity at 1 meter is 20 watts per meter squared, what will be its intensity at 5 meters? So this is the R. So this value that's given is R. R is the distance away. So remember this picture here? This R. That's 2 times R. That's 3 times R. R is the distance away from the source. Now, the reason why we use R instead of D is because it's an isotropic source. The same R will go regardless of whether you're standing here or here or here. Doesn't matter where you're standing. At that radius away from the source, you would have the same intensity. Great question. That is why we can't use D, because the reason why we use D is because it's the same distance, right? But in this scenario, it could be anywhere in that area. If you're standing on that circle, you should hear the same concert. the same loudness, the same intensity. Yeah. Sorry, that I didn't make that clear. Thank you. Does that make sense? Yeah. Put this in a, that's kind of important. And there are more examples in the book. There, they should help you with homeworks. Yes. The what? Oh, yeah. Okay, so this would be I equal P over 4 pi R squared. The power is given as 20 watts per meter squared divided by 4 pi. R is given as 5. So it'll be 20 divided by 4 pi 5 squared. So intensity will be, yes. 0.06 watts per meter squared. This shouldn't be meter squared.